Hello, and welcome back to another learning clip. This time we're going to be learning about effect sizes. By this point, you should be relatively familiar with the term p-value. If not, I suggest having a look at some of the previous videos provided, since a p-value really is the heart and soul of statistics. It tells you whether or not there is a difference between your groups. A p-value only tells us if there is a difference, not how big that difference is. Now, I'm sure you can see how it might be useful to know how effective an intervention is. So let's do some research. Let's help some people out, improve their lives, improve our lives. Let's improve the productivity of our staff. Caffeine is well known to improve productivity. It's why tired people drink it. It puts a bit of pep in your step. Right now, we give our staff some classic Starbucks Pike Place roast. This has about 235 milligrams of caffeine per cup. But would it be better if we switched out our coffee to something called Black Insomnia Extreme Caffeine, which has about 1,105 milligrams of caffeine per cup? That'll wake our employees up and get them hyped for the day, we think. Let's recruit some participants. We need to entice 100 people into our study. Hey you want some free coffee? No? Too bad. Remember, if self-selection is not working out, you can always switch up your sampling methods. In this situation, I think I'll go for simple random sampling. I'm choosing who participates at random, and they aren't really being given much of a choice. Now, we need to split up our lovely, willing participants into two groups. Group 1, you're the control group. You get a nice, fresh cup of standard Pike Place Starbucks roast. Enjoy your 235 milligrams of caffeine. Group 2, you're the test group. You get a hot cup of Black Insomnia. Enjoy your whopping dose of 1,105 milligrams of caffeine. We make everyone drink 1 cup of coffee. We wait an hour, and then we have them do a test to measure their productivity. This gives us a measurable result, sometimes called ratio data. Our Starbucks group does fine on the task, getting an average score of 80. Our Black Insomnia group is bouncing off the walls, but they still manage to get an average score of 90. Our means are different, but are they significantly different? We'll have to do an independent t-test to find out. Hooray! T-tests are fun, t-tests are great. Take 2 groups and differentiate. We run our test and get a p-value of less than 0.001. That is definitely less than 0.05. This result is indeed significant, meaning we can say with great confidence that there is a difference between our 2 groups. Looking at these results visually, we would see 2 confidence intervals that don't overlap very much, or perhaps not even at all. But do our confidence intervals look like this? Or this? Or this? All these comparisons have a p-value of less than 0.001, but what differs is the effect. We measure effect size for t-tests and ANOVA using something called Cohen's d. Cohen's d relies on how big the difference between the means are, as well as the standard deviation of the sample. But before you go getting all panicked, don't worry. You don't have to know the formula or do any math. All you need to do is click one simple little box. See? It's that easy. Our little stickman researcher is saying, "Oh wow, that was so easy. I can't wait to see the output window and get information to make the best decision possible." So let's not keep him in suspense. The t-test output window. It's probably not a bad idea, and dare I say it, maybe even a great idea to learn how to read these tables. Let's go through it in a simple 4-step process. Step 1, check Levine's test. Oof. Oh no, it's significant. That means our data is not evenly distributed. Let's go to step 2 to figure out what to do. Okay, we have a large enough sample size that we can safely read row 2 of our output table. Yay! Find that p-value is step 3. We care about the one-sided p-value because we wanted to improve things. Hey, check that p-value. Nice and significant. Step 4. What is the effect? Well, here we have a table with Cohen's d, and we look at the point estimate. Here we have an effect of 2.388. That is a huge effect size. But what am I basing this value on? Cohen's d is normally split up following this chart, so we can see that since our effect size is bigger than 2, it's considered a huge effect size. In terms of confidence intervals, it means our confidence interval probably looks something like this. In general, as the effect size increases, the width of the confidence interval will decrease because the sample mean difference will become more reliable and less affected by sampling variability. So, with a Cohen's d of 2.3, we might expect the confidence intervals to be relatively narrow, indicating a strong and statistically significant difference between the two population means. And now we can say that black insomnia coffee will not only give a significant increase in productivity, but we can say that the productivity increase will be quite large as well. Or that changing the coffee has had a big effect on productivity. Thus, we ignore the health warnings against consuming too much caffeine and switch out the coffee. Indeed, productivity increases, but something else is happening in the office now. People are starting to complain about severe headaches and increased anxiety. The initial spike in productivity is starting to decline as people are needing to drink more and more of the coffee to get the same results as previously. There's a small group in the office who are unaffected. Turns out these people don't drink coffee as they prefer a nice cup of tea instead. Looks like we need to do some more research to determine if the increase in these health problems is related to our black insomnia coffee. Sticking to random sampling, we grab 50 people who drink tea and 50 people who drink coffee. We have a survey to determine whether someone suffers from headaches and anxiety, and we give this to both the tea group and the coffee group. This sounds like categorical data, also known as nominal data. Looks like we're going to need to use a chi-squared test on these poor headachy people. But, our researcher chimes in, how can we measure effect size? Cohen's d is all about the mean. It's great for t-tests and ANOVA, but not so much for the chi-square. Researcher, you are so right. We cannot use Cohen's d here. We have to use something called Cramer's v. It will give us a value between 0 and 1, and the closer it is to 1, the stronger the effect size. It's similar to the correlation coefficient in that way. Fun, right? No? Well, to each their own. Let's get back to our coffee-addicted staff. We do all the steps to run a chi-square, and to get Cramer's v, we just click one extra button. Yes, it's that easy. Okay, here's our output window. Let's go on a hunt for our important numbers. Step 1. Does our expected cell count have any violations? No? Great! Step 2. Let's find our p-value. Bam! There it is. Less than 0.001. Lovely. Super significant. We can be very sure there's a difference between our coffee group and our tea group. But how much is consuming all that caffeine negatively affecting our poor staff? Cramer's v will give us that information. Here we go. Step 3. A nice Cramer's v value of 0.486. Based on this handy-dandy chart, we can see that this is a relatively strong impact. Alas, it seems our best course of action is to say goodbye to the black insomnia coffee for the sake of our employees. Sure, productivity went up for a while, but it had done so at the cost of the health of our employees. Not ideal. It's back to the drawing board for our researcher to find a new solution to fix productivity, preferably without any negative side effects this time. Let's recap. A p-value tells us if there is a difference. Cohen's d tells us how big of an effect there is for a t-test or an ANOVA. The higher Cohen's d, the bigger the effect. Cramer's v is used to measure effect sizes of the chi-squared test. Cramer's v presents as a number between 0 and 1, acting similar to the correlation coefficient. If you have any questions, comments, or concerns, please make a note and bring them to class, where either I or my colleagues will endeavor to explain further. Until next time!